Hello everybody, and in this video we'll start our third module of the class, and it's the data-driven cybersecurity, and we'll talk about the data source. So I will go ahead now and start sharing my screen. So in our module today, we will discuss the ways how to get the data, and not only packet data or activity data, but much more than that. It's the logs and some alerts and this kind of stuff. So we call our module here cybersecurity data sources, and our outline will look like that. We'll talk about the cyber data analytics. We'll talk about the packet capture and the data that we can get out of the packets. We'll talk about firewalls, logs, and how they operate, and what is the type of devices from the point of view of data, as well as we'll discuss the IPS and IDS, and then we'll see how we can collect all this data into a CM or a vulnerability management system. We'll have a brief look on the operating system and why we care about understanding the operating system and the application data and the relationship between them. So first of all, let's start to define the cybersecurity data analytics. They call it's a discipline that employs various techniques, strategies, processes, and tools to diagnose, predict, and prevent unauthorized access of a network system or device, which in our case, the device is not only a hardware device, it can be a software device, can be a virtual machine, it can be even a file storage or even a directory on your machine. It's very important to notice that we have to not only concentrate on the techniques or the processes, but also the strategy that brings them into life, because you can have the best tools and the best technology, but if you don't have enough strategy to make it alive, you're actually not getting any benefit out of it. And the processes here is not only how to run a specific tool, but also it talks about the SOP, which is a standard operation procedures, what to do in every possible scenario. In this case, you make it easier, not only on the specialists that work in the IT field or the network monitoring or network security right now, but also if you have a new specialist who coming into your company, how to train them, how to make them aware of what's going on to minimize the human error, because most of the case, all the attackers are looking for human error so they can get benefit of it and they can get into the system. So let's a little bit more details here. So other than the operating system and the processes, where we can get the data? We can get the data from different sources. You need to be careful to see that your main data source will be some files and something that produce your data, continuous data that you actually don't have to generate it yourself at all, which is like the network packets. In the example of the network packets, it's your pure data source. It tells you what happens in your network, what's going on there. Every single activity and every single communication between machines are determined by some packets that goes to your network. Firewalls also a good source of data, but it's not a data source. Make sure that you clarify this point. It provides you with log, but it never generates data. Imagine the data is coming from like type of geyser that just give you data out of it. So the firewall doesn't do that. The firewall just look at the traffic and take actions whenever something happens. And usually it's doping of packets whenever there's some wrong connection or unauthorized access to your network. Other thing is the IPS and IDS. Great tools for intrusion detection, intrusion prevention system. But again, they are not data source. But in this case, they are similar in the firewalls that they are not data sources. But the difference here, They don't provide you logs anymore. They provide you with alerts. They tell you whenever there's an attack happen or was about to happen and intercept it. And the fourth part here is operating system. Operating system is actually a pure data source. Why? It gives you the information about the applications that are running now. It gives you data about event log, if something happens or something crucial, or just information that goes on to the system, as you can see in the next slides, and give you a lot of information about the updates, about the security access. A lot of us use Windows or Linux or Mac machine, and we all know about the event log where you can go and see everything that actually happened in your machine. This is part of the log, but the data source itself is the activities that you have within the operating system. As a reminder, this is the 4 items that we have. First of all, network packets. Second thing is the firewall, IPS and IDS, and operating system. And the important thing here, if every component works individually, it doesn't give you much. But whenever you can combine all of them in one centralized or one container to pull all of them, this is when you can get extra data that is not seen whenever we use each individual component as a standalone component. But combining them, this is the first step to make something new, something more smart, something that can be taught to a machine to provide machine learning. So let's start by the packet capture. And to start with the packet capture, we need to talk about network packets. So what is the definition of the network packet? The network packet is a formatted unit of data carried by a packet switched network. Computer communication links that do not support packets such as traditional point-to-point communication or telecommunication link simply transmit data as a bit stream. Example of it, whenever you have a printer communicating to your machine using a USB port, they don't have packets much. They just have a stream of data with some header and trailer that tell you where is the beginning and where is the end, and some protocol that goes the data to them. So this is a type of a network that doesn't have packets, but the whole communication can be considered as a packet itself. Why it's not a packet? Because there's no stack of communication. And this is where you can feel the difference. It was an intermediate step between going from parallel cable to serial cable, from serial cable to a network. And you can see even how much amount of cables was saved by using serial and packet switching later on. It's also important to note that the data formatted into a packet or a packet switching is possible and can be broadcasted through a lot of communication medium in not only one pass, but different passes. And this is why they call it packet switching circuits. Whenever the packets goes through the network and you don't have control exactly what path they will take every time, this is when you can have a lot of attack or interception or man-in-the-middle attack and all of this type of unclean communication, I can say. So by understanding the packet itself, it will give you a very good edge here to know where you are and which packets are good and which is bad. Using the firewall can block or drop the packets they are not correctly assigned to a specific stream. But just to remind ourselves here, what is a network packet? Any communication to the network, because most of the time we're using TCP/IP right now, it have to build a stack. A stack is just a type of simplification of the network processes. We know already from our network class or other security class that we have the TCP/IP model and have 5 layers, including the physical layer, starting from top at the application, then the TCP, IP level, Ethernet driven, and the cable itself with the physical layer. The application uses only the data. TCP layer, the session data, will put a small header at the beginning to put the user data. The header usually tell you what port to use and so on. Then you will go to the IP level where it have the IP addresses for the source and destination part, and you drop every level puts a header in the beginning and transfers the rest of the data down until you reach to the physical layer. In the physical layer, it will add also a trailer at the end to determine where is the beginning and end of your packet. And whenever the naming is different here with every layer, when you have a segment, packet, and frame, and at the end you have the Ethernet frame that you can send over the cable. And to look at how the communication here, and already all of us are expert in network, but just a small reminder, whenever you have a sender, go to application layer, transport layer, network, data link. All of them will be building the packet. At the end, go to the physical, you send the bits out, and never go to the recipient to go the opposite way in decapsulation, dropping the frame and the header, getting what's inside, pushing to the next or the above layer. Again, throwing the header, getting what's inside, throwing the header, and get at top to the data. And this is how the communication goes. Whenever you send the physical part here, this is where you can get the tag, because everybody can see this, especially if you are on a Wi-Fi network. Of course, you can use encryption or anything like that, but again, it's shared. Everybody knows what you sent on the internet. Every time you type your social security number or your credit card, it's there. If somebody really wanna hack it, they're gonna hack it. So, but they just need to know where it is and how it's represented. Talking about that and looking at the network packet, this is how it this is how it looks at the end. You have the MAC addresses of the recipients, sender and receiver within the frame. In the packet itself, you have the recipient ID and sender IP. Sorry, recipient IP and the sender IP. In the segment, you will have the protocol number and the data itself that you sent. And digitally or byte-wise, how we look at it, usually it looks like that. This is the IP header, as you can see. Usually it will tell you what is the version number, what is the IHL, type of service, length of the total header, and so on. Control bits, as you can see, the segments, how far till you reach the data itself. Then you will go to the TTL, which is time to live, the protocol, what type of protocol you use, header, then you have the source IP address and the destination IP address. And then you have the options here, and then the data goes. I usually advise my student to look at the data of how at least the data looks in the packet header, so they can be familiar whenever they see it in Wireshark later on, they will understand what is going on. Because, for example, the control bits, they're very important to see, because whenever the attack, like one type of attack, if somebody of you took the cybersecurity principle of cybersecurity class, you can see that playing with these small bits can actually get your packets out of order and everything. So it's really, I really advise students to spend at least 1 hour every semester, just whenever they take any cybersecurity class, to just refresh their memory, because after a while you will forget what's inside the packet, but it's a good way to remind yourself. And if we can look at the sender receiver communication, I like this illustration here because it shows you how this should be, the HTTP request goes, how the header will put TCP header, then the IP header, and then the data link will put the addresses of the MAC addresses and will send the request. Whenever you go to any router, the router have also the stack of the TCP IP, but only the first 3 layers, still the network. Like from here, I already know that this is a router. Why? Because it started to go to the level 3, which means it understands IPs. If it was only a switch, it will be only 2 layers till data link to just understand where is the MAC address in the subnetwork that it controls. But now, as soon as I see any device that have 3 layers, and I know even without looking at the name, it's a router. And then it goes to another router here on the road, and you can see how it changes the destination address through the routing table till it reach back to the receiver or the destination port, then go to decapsulation till it reaches IP. I like this presentation because show you how what's going on in the network. And usually regardlessly it's an attack or not, they will use the same structure as you can see, and we will continue that in our next video.